Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all to the next session on the subject of system programming with Linux. The title of today's session is Version Control Systems, and the VCS we are going to dig out and understand in detail is Git. So in today's session we will first talk about different types of revision control system, and then we will specifically talk about Git. And we'll see the detailed working of Git, including initializing a Git repository, adding, committing files to that, viewing logs and its status, deleting, renaming and comparing files, ignoring files, undoing changes and moving to old commits. So let's start playing. Well, a version control system, also called a revision control system, is a software tool that records changes to a file or a set of files over time so that you can recall some specific version later. Before version control systems exist, we used different ways for maintaining versions of the file. For example, using save as for every new change made to a file and making a copy, and then giving a version number and date of update to that file. Well, dear students, version control systems allows us to maintain a history of different versions of a file. It allows us to move back and forth between these versions, compare different versions, merge different versions of same files to create a new version, lock other users when one user is altering a file, and perform conflict resolution. Let us first talk about the three different types of version control systems. And the first type is local data model. Well, this slide shows the working of a version control system that is based on local data model. Suppose we have a file on our system and we want to track its different versions. Instead of saving the complete new version of the file with a different name, we let a version control system to handle or control the versions of this file. So instead of saving the entire file, the version control system saves only the change set or the snapshot between the two versions of the file. The version control system maintains a version database, also called a repository, that keeps track of all the changes made to that file. You can apply the changes set to one version of the file and get the other version. Let us see some example versioning tools that use local data model. The first is source code control system. It is written in C, developed by AT&T and bundled free with Unix. It is not the first VCS, rather the first to become popular. The source code control system keeps the original file as it is, and instead of saving the complete new version, just save the snapshot of the change. And if you want version 3 of a file, you take version 1 of the file and apply the two change sets to get to version 3. The other example that uses local data model is RCS, Revision Control System. Written in C, developed at Purdue University. The SCCS was for Unix only, while this revision control system was for personal computers as well. The revision control system keeps the most recent version of the file in its whole form, and if you want a previous version, you make changes to the latest version to recreate the old version. So RCS is faster than SCCS, as most of the time we need to work with the latest version of the file. Well, there are limitations to local data model. You can track changes in a single file and not in a set of files, and only one user can work with the file at a single time. So multiple users or team members cannot collaborate and work on the same project. So let's talk about the second type, that is the centralized data model. Well, this slide shows the working of the version control system that follows the centralized data model. In this model, there is a server machine that holds and maintains the version database. This version database or repository keeps track of different clients working on different files. Suppose there is a file and different users wants to work on it. The file is kept on the server and the versioning tool is instructed to keep track of different versions of the file. A client sitting at computer A check out a specific version of the file to get a local working copy of the file on his or her computer. He or she works on the file by making deletions, updations, or maybe adding new contents in the file, and finally performs a check-in or commit operation to write the changes from his or her working copy back to the repository, and thus makes the latest version of the file available to other users for further development. So this is how the versioning tool that follow the centralized data model works. Let us see some example versioning tools. Concurrent version system. Written in C, open source, available for Unisys as well as for Microsoft Windows. Introduce the idea of branching. We will see what branching is in our next session, inshallah. The limitation of CVS is it lacks atomic operation and no file renaming is allowed. The other important versioning tool that follows centralized data model is Apache subversion system. It is also written in C, is open source, cross-platform, and is faster than CVS. It supports atomic commits, can track directories so you can rename files, and it can also track non-text files like images. And we of course have limitations of centralized version control system as they have single point of failure, and you cannot collaborate with fellow developers if the server is down. And last but not the least, developers do not have history of project on their local machines. So let's move on to the third type of version control systems that follow the distributed data model. Well, in distributed data model, a user or client don't just check out the latest snapshot of the file, rather fully mirror the entire repository or the version database as well on his or her computer. So on this slide, you can see the version database or repository is there on the server computer as well as on the two clients' computers, computer A and computer B. So the versioning database is there on all the computers. So in distributed version control system, every user or developer works on his or her local repository, and changes are finally pushed or committed on the remote repository at a separate step. So in case of a server failure, any of the client repositories can be copied back to the server and restore it. This is the most common model these days, and all the latest versioning tools follow this model. Let us see some example versioning tools that follow this distributed data model. First is Bitkeeper. Written in C, is proprietary and closed source. A community version of Bitkeeper with limited functionalities was free, and it was that which was used to manage the Linux kernel source code from 2002 to 2005. In April 2005, the community version of Bitkeeper stopped being free, and it was then Git was born. Git was developed by Linus Torvald in 2005. It is free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It is compatible with all Unisys and Microsoft Windows, written mainly in C along with TCL, Perl and Python, which are all general purpose interpreted dynamic programming languages. Okay, so before I start with the installation and configuration of Git, let us first move on to the official website of Git, git-scm.com. Over here you can see the download link. I have opened it for you. You can download Git for Mac OS, Windows as well as for all Linux distributions and Unix. We have the GUI clients available for the GUI lovers, and the GUI clients are SourceTree, Tortoise Git, Git-Cola, git-I, and many others. But as usual, I will be using the command line version for better understanding. And dear students, later switching to a GUI tool will be a piece of cake for you. So let us move on to our Linux terminal and do the installation of Git. You can install Git with this command. I have already installed Git. Let me check out the version. And I have the version 2.15, and the Git is installed in US or bin directory. The first thing you need to learn is how to get help about Git. You can use Git Help, which will display you all the commands about which you can ask for help. You can do man git to see the man page of Git, which says that it is the stupid content tracker. Well, it is always better to use Git Help instead of using the man command. You can use Git Help Git to see the man page again. You can use Git Help tutorial. This will show you a basic tutorial that explains how to import a new project into Git, make changes to it, and then share those changes with other developers. Please go through it when you have time. Git Help every day. This is a useful minimum set of commands. I show you the basic commands used by the 4 categories of Git users: the individual developer, collaborators, integrators, and repository administrator. Do read this man page at the time of your convenience. Okay, dear students, let us start with the basic configuration of Git. Well, there are 3 places where Git stores the configuration information. The first is in the file /git config. Right now it is empty. The configuration in this file, if available, apply to all the Git users on this system. So these are called the system configuration. It is always better to apply the per user configuration. And the per user configurations are there in the file ~.git-config. Let me remove this file as well. ~.git-config. Once you will try it for the first time, there will be no such file on your system. And later I will create it. But anyway, this is a hidden file .git-config in every user's home directory. And this file contains user configurations. And the third type of configuration are done on project basis, called the project configuration. And these are kept in the config file in the .git directory, which is there in every project. Well, we can edit these files directly, but better is to use a command config for this. Let me do the user configuration to make you understand. Git config -- system, and after this, whatever I will write, this will go to the system configuration. And if I want to add the user configuration, so I will use git config -- global. And if I want to use per project configuration, I will use git config -- local. So let us do the user configurations, and that is using global. Uh, there are two minimum required configurations you must keep if you want to use Git, and the first is user.name, and let me give the username as Arif but, and the other is user.email, and that is Arif at pucit.edu.pk. Let us see these configurations. Git config --global -list. It will show you the configurations or user configurations that are there in the file in my home directory git config. So you can see previously this file was not there, but now this file contains certain parameters related to the user, that is the name and the email. Well, this is the minimum configuration that you need to do before you start Git. You can do some more as well. Let us tell Git to use colors in its output. Git config --global color.ui is true, and let me set the default editor of Git to Vim core.editor, and let me set it to Vim, and let me check. Yes, all the configurations are there now. If you want to see some specific configuration, you can use git config --, instead of writing list over here, you can say user.name. So it will just display that particular global setting. Okay, let's start with the Hello World Git project now. Right now, let me create a directory hello-git. Let me cd to this directory. Let me do ls. So hello-git is an empty directory right now. To tell Git to keep track of all the files and directories that come and go in this directory, we need to do git init. So this will initialize an empty Git repository over here. It has created a hidden directory in this project directory whose name is .git. And if I do ls-a.git, you can see 5 directories and 3 files in this hidden directory .git. This is actually what we call the version database or repository. This .git directory stores all the tracking information for the files and directories that come and go inside the project folder, that is hello-git. If you want to remove the version control from your project, you simply delete this .git directory. Sometime later in this session, we will see the contents of these files and directories, but for now let's keep things simple and move ahead. Let me do clear. Okay. So dear students, before we start adding, editing, modifying files and subdirectories in this project, let us first have an overview of basic workflow of Git. Let's move on to the slides again. Okay, so this slide shows the 3-tree architecture of Git. You can see the working directory, the staging area, and the repository. These are the 3 trees that Git uses. Let's first talk about this working directory. A working directory is any directory on your file system that has a repository associated with it. So any directory having a .git directory inside is called the working directory of your project. And that top level project directory may be having a lot of files and subdirectories in it. The second directory tree is called the staging area or sometimes staging index. It is an intermediate area or cache that exists between the working directory and the repository. Git normally does not commit changes directly from the working tree to the repository. Rather, changes are first made in the staging area. The third directory tree is called the repository of the or the object store. This repository actually holds the changes of your project over time as you perform the commit operations. This repository is found in the .git subdirectory within the project root directory, which we have just seen on the terminal. The primary data structures of this repository are blobs, trees, commits, and tags. So you work on your working directory, create the files, edit them, delete them, then you add those to the staging area and then you commit those changes to the repository. Let us move back onto the terminal. So we have already created our project directory and have done git init in it, and you can see the .git directory over there. Let me create a file over here with the name of readme, and let me write this is readme file for our project. Let me save and exit. Let me do a git add. This will place the file in the staging area. Let me do git commit and give a message creating a readme file for our project. Well, it gives a message that it has created the readme file and the create mode, and it has done the insertion. Well, this -m that I have used over here is used to associate a short descriptive message with this commit. Well, dear students, let me use some help about these commands, and the two commands that I have used is add and commit. Let me first use git help init. So git init is used to create an empty git repository or reinitialize an existing one. Let me use git help add. This is used to add file contents to the index. Please do read the description as well. Git help commit. This actually stores the current contents of the index in a new commit object. Do read this man page at the time of your convenience again. And over here, let me create another file and repeat this, whatever I have done. Let me create another file. The author of this project is Arif. Let me redirect this to file authors. Let me do ls. You can see the authors file is also there. Let me do git add authors. I have moved this authors file from the working directory to the staging area. Let me do commit. Over here I have not given the -m option. If you do not give -m option, the default Git editor will open for you, and you should try to write a good descriptive commit message. And a part is already there. New file authors, and let me write down creating new file authors. Let me save and exit. So it has associated this message with this commit. Let me create another file, echo temp file, and let me redirect this to temp.txt. Okay, oops, let me control C. Okay, so this shouldn't have been there. Let me do git add this to staging index, git commit, and give a message. Okay, so now there are 3 files. Let me see the log now, the git log. Well, you can see 3 commit objects are shown with the latest commit at the top. This is one commit, this is a second commit, this is a third commit. Rather, this is the first, this is the second, and this is the third. The latest is at the top. On the first line, you can see this 160-bit hash value displayed as 40 hex characters. Well, dear students, every commit object is associated with a hash generated by Git using SHA-1 algorithm, normally called SHA algorithm. So we can say that Git repositories are secured with a cryptographically secure hash algorithm. This protects the data and its change history against any accidental or malicious change. After this commit, you can see the author, his email, the date timestamp, and the message. And over here as well, this is the first commit in which I have given the message creating a readme file. This is the second in which I have said creating a new file authors, and this is the third commit. Okay, let's see the help page for log. Git help log. Do make it your habit to see the help page of Git. Okay, let me use some options of it. Git log -- one line. So it will display a one-liner information about every commit object, a portion, initial portion of the hash, and the message. Over here it has shown you a lot of information, and over here it is showing you just a single line information. Similarly, if you can do git log, and if you want to see just the commit objects of a particular user or author, you can say author is equal to Arif but. So if there are multiple users who are doing commits on this repository, you can find out who has committed what commit objects. Okay, one more thing that I just want to touch upon is this line. Well, with the latest commit, you can see this head arrow master, which says the head is pointing to this commit on the main branch that is called the master branch. I will talk about branches after some time. Right now, let us move on to the slides again and try to understand the concept of commit object and this head pointer. Okay, commit objects first. Suppose you have made 3 commits in your project. That means there are 3 change sets. Each commit object refers to a change set, and this figure in front of you illustrates how the series of these commits are linked together. You can note that how the change set C contains the cryptographic hash, the author, the message, the timestamps, and the pointer to the parent. And this is the second commit, and which contains pointer to the previous commit. So from these commit objects, you can find out who has committed, when, why, and with what changes. Let's talk about the head pointers for a while. Well, dear students, Git maintains a reference variable called head, which points to a specific commit object in the repository. As we make a new commit, the head moves to point to the latest commit object. Let us see an illustration to understand this. In the very beginning, when you do a first commit, the head points to the only commit object. Once you do another commit, the head also moves ahead. On a third commit, heads move ahead. And on the fourth commit, heads again moves ahead. So head always points to the latest commit object. And whenever you do another commit, heads moves to that location. Let us move on to the Linux terminal and see this head pointer over here. Let me clear screen. Let me do ls-a. Let me do ls.git. In this git directory, you can see this file head. Let me do a cat to this file. And this is a file that contains a path to another file. And right now it contains a path to this master file in the refs and the heads directory. Let me do view that inside .git refs heads master. If I see this, you can see this hash, and well, this is the latest commit hash, ID of the latest commit. Let me show you it this way. And if you see the log, you can see this is the same hash which we have over here, 7E907BB. So let me say that this head pointer always points to the tip of the current branch. And for the time being, just keep in mind that a branch in Git represents an independent line of development. And every Git repository has at least one branch that is called the master branch. And that is why you see over here that head points to this commit on the master branch. Now that we have more insight of the workflow of Git, let us now add new files to our project, edit, delete, and rename them. And meanwhile, keep checking the log and the status of our Git repository. Right now I'm having 3 files over here. Let me edit the authors file. Open it in Vim. Let me say the author of this project is Arif Bhatt. And let me add a new file from directory above prog1.c. And let me copy it to this directory and let me do ls. You can see another file over here. Let us now see the status of our Git repository. Git help status. This shows the working tree status. Do read it and let me run this command git status. Well, actually this command compares our working directory with the staging index and repository. And right now it is telling us that this authors file has been modified and there is a new untracked file prog1.c. Let us tell Git to track the file prog1.c by adding it in the staging index. And we know the command to add, and that is git add prog1.c. Let us check the status again. Git status. Well, now you can see that prog1.c is being tracked now and has been added to the staging index, while you can see the authors file is still being shown as modified. It is modified in the working directory, and it is different in the staging index as well as in the repository. If I do git add authors and check out the git status, now you can see that both the files prog1.c and authors have been added to the staging index, and now we can add them to the repository by using the git commit command. Let me say git commit, and let me give the message editing authors file and creating prog1.c. And now let me check the git status, and it says nothing to commit, working tree is clean. By this message, Git wants to tell me that all the three trees are synced with each other. That is, whatever is there in the working directory is there in the staging index, and the same is there in the repository. Let me move on to the slides again and brush up these concepts a little bit. Okay, well, this slide shows the life cycle of a file in Git. Each file in the working directory can be in one of two states, untracked or tracked. Well, this untracked means all the files that are just created and have never been in the staging area or the repository, while all the files which have been added at least once or that were there in the last snapshot are called the tracked files, and the tracked files can be either unmodified, modified, or staged. By unmodified, I mean the copy of the file in the working directory is the same as in the staging area and the repository. By modified, I mean the copy of the file in the working directory is different than the file that is there in the staging area and the repository. And if the status of a file is staged, that means the copy of the file in the working directory and staging area is same, but it still needs to be committed to the repository. Let us move back to the terminal again. Well, the status says nothing to commit. That means the working directory, staging area, and the repository, all three are synced properly. Now we know how to create new files and edit them in our project's working directory. And we know how to add them to the staging index. And we know how to finally commit them to the repository. Let us see how we can delete the files. To delete a file, let me first create two files, touch F1 and F2. Let me check the Git status. You can see these are the two files that are untracked because they have never been added to the staging index or the repository. Let me say git add F1, F2. Let me use git status again. Now it says that the files have been added to the staging area and they need to be committed now. Let me commit them by the message created F1 and F2. Let me check the status. Now the working tree is clean. Okay, so we have added two files. Let us remove them. To remove a file in Git, we have two options. The first option is remove the file using some operating system command, add that information to the staging index, and finally commit. Let's do that. rmf1. You see the file is deleted from the working directory. Git status will tell you that the file has been deleted, but only from the working directory. Let me add this information to the staging index and let's check the Git status. It says that this change has been staged in the staging index and you need to commit it to add it to the repository. Let me do that. Let me do git commit with a message. Let me check the Git status. It says it's clean. So one way to remove a file is remove the file using the rm command or maybe some GUI tool. Add that information to the staging index and do the commit. The other option is tell Git to remove the file and then just commit. Git rmf2. Let's check the status. You see Git has deleted the file as well as added that information in the staging index in one go. Now we just have to do a commit. Git commit -m f2 deleted. You can see the working tree is clean again. So after deleting file, let us rename a file. Okay, to rename a file, once again let me create two files for review again. Let me add both these files to the staging area by git add command. And let me do git commit. Again created f1 and f2. Let's check the Git status. So it's clean. The way we can delete files in two ways, we can rename files also in two ways. Option 1 is use some OS command to rename, add that information to staging index, and finally perform a commit. So let me show you again. We have two files. Let me rename file f1 to file 1. Let me check Git status. Well, it didn't tell us about renaming of file. Rather, it tells us that file f1 is deleted, as you can see over here, and a new untracked file, file 1, is added to the working directory. Let us add these two changes to the staging index. Git add file 1 and git rmf1. And let's see the status of Git again. Well, now Git is recognizing that file f1 is actually renamed to file 1. So we just need to do a commit now. Renaming f1 to file 1. Okay. Let me check Git status. So it's clean. So f1 has been renamed as file 1. So in this option we use the operating system command mv to rename. We added that information to staging index and we finally performed the commit. The other option to rename file is tell Git to rename the file and just perform a commit. Git mv f2 to file 2. Let's check Git status. And this time you see Git has recognized that I'm actually renaming the file f2 to file 2. And now I just need to do a commit. with a message, and that says renaming f2 to file2. Let's check the status again. So it is clean. Let me check the log. So you can see the log has gone too much. Let me do the log in one line. Well, yes. So these are the different commits that I have made, and the final commit is renaming f2 to file2, and that is where the head pointer is seeing right now. Okay, dear students, now we know how to create, edit, delete, and rename files in our working directory. We know how to add these changes to the staging index, and we also know how to commit them to the repository. Let us do something else. Let me do cprog1.c. So this is suppose a very basic program that asks two numbers from the user and adds and display their sum. Let me do gcc -c prog1.c to create the prog1.o. Let me do gcc prog1.o and create it with the name of myexe, and let me do ls. So you can see two new files over here. One is myexe and the other is prog1.o. Let us see the git status. Well, it is saying that there are two untracked files, myexe and prog1.o. Well, dear students, every time we compile, these files will be created, and Git will prompt us to commit these changes, which I think is undesired. So we need to tell Git to ignore these files. And the easiest way is to do on per project basis. That is, you can create a .gitignore file in your project root directory and write the names of these files that you want to ignore in that file. Let us do that as well. Let me create a file vim.gitignore, and I need to create it over here. Well, yes. Let me write down the names of the files which I want to ignore. I want to ignore myexe, maybe the name a.out, and maybe all the files having the extension .o, and maybe all the files having the extension .tar, .gz, and maybe others as well. But that is enough for the time being. And let me add this gitignore file to the staging index, and let me commit this file because Git must not ignore this file .gitignore. Okay, now let me see the status again. You can see it says the working tree is clean. Although there are still untracked files, myexe and prog1.o over there, but it is ignoring them. So this is how you ignore files on per project basis. You can also ignore file on per user basis by setting the configuration parameters core.excludes file. But anyway, I think on project basis it's okay. Okay, you see the files are still there, but it says it's clean. If I do gcc prog1.c, you can see a new file a.out has been created. If I do git status, it again says the working tree is clean because it is ignoring a.out, myexe, and all the files having .o extension. Okay, so far so good. Well, dear students, let us see one more thing. Okay, let me use vimprog1.c. So this is a file. Let's suppose that this is a program on which I am working, and let me add a new line over here that says hash include stdlib.h. I add a new line over here, and suppose let me delete this line, and suppose let me edit this line. So what I have done is I have added a new line, I have deleted a line that was there, and I have edited this line. I have removed a semicolon from here. Let me save and exit this file. Let me gcc prog1.c, and you can see I have errors. So the file prog1.c, which is there in this working directory, has errors, but the file which is there in the staging area, or the file that is there in the repository, is the one which was a good file, which I compiled and executed before. So let me compare the contents of the files. So I can do that with the diff command, git diff prog1.c. So this will show the difference between the copy of the file prog1.c in my working directory and the copy of the file prog1.c in the staging index. And you see they are different. It says that there is a new line shown with the plus sign, and it shows that this line has been deleted because there is a minus over here. And over here you can see a minus and a plus sign, and you can it means that this line has been edited to make it this line, and you can see there is a difference of semicolon. So this has compared the prog1.c in the working directory with the prog1.c in the staging index, because I have used this command. So this command has compared the file prog1.c with the prog1.c in the staging index. And if I want to compare the file prog1.c in the working directory with the prog1.c in the repository, I will use the option head over here. And this also shows you the same differences. And if I want to compare the prog1.c file in the staging index and the repository, I can use --staged over here, and it shows nothing. So that means prog1.c in the staging index and prog1.c in the repository are similar. Okay, so what to do? So dear students, since this is a small file and there are just 3 changes, and that is I have deleted this line, and I have edited these line, and I have created this complete new line, so I can change them and correct my program. But what if the program is too big and I have made lots and lots of changes in different parts of the file? And so in that case, the best solution is to bring the final updated version of prog1.c from the repository to my working directory to undo all the changes that are unwanted. Let's do that. And the command to do that is git checkout --, and then the name of the file prog1.c. And now if I do cat prog1.c, you can see the new version, the version that is there in the repository, which is not having the new line over here, and this line was deleted and it is there, and the semicolon is also there. And if I do gcc proc1.c, you see it compiles without any error. And if I do git status again, it says the working directory is clean. So if you are working on a huge program file and you have made some changes and you want to undo them, the easiest thing is get the original copy that you saved in the repository back in your working directory, and that you can do with the git checkout option. And this double hyphen I have used actually to tell git that I'm checking out a file and not a branch. In the next session we will see how we can check out a branch, inshallah. Okay, one last thing before I close this session is moving to an old commit and restart doing things from there. Let us see this on the slide first, and then we'll fall back onto the terminal. Well, dear students, we can move the head pointer to some previous commit and start recording the commits from that commit object onwards. Well, there are three ways of doing this: the soft reset, mixed reset, and hard reset. Well, we will do the hard reset because it will change the working directory as well, and you will be able to understand it properly. If you want to do the hard reset, you use the --hard option, and you give the commit ID to which you want to move the head to. So after a hard reset, head is moved to the specified commit ID, the staging index, and working directory. Both will match your local repository. Let us move back over here to the ls, and let me remove these files for a little better understanding. Okay, so we have these files. Let me check git status. It is clean. Let me do log one-liner. So this is log. Just note the latest ID. This is the latest ID. You need to keep track of this. If you lose this ID, you will not be able to fall back to your latest commits. Let us do the hard reset, which will change all the three trees to the commit of our choice. And let's suppose that I want to move my working directory tree to this commit ID. Let me copy this, and let me say git reset hard, and let me paste this over here, and let me put an enter. And if I do a ls, you can see the only two files over here. And if I do a git log one line, you can see the head has moved to this commit. That is the second commit. And there is no file f1 and f2 or file 1 or file 2 and dot git ignore, nothing is there. So you can restart and start moving ahead. And if you want to go back to that, you can copy this commit ID, which you must save somewhere, and give the git reset hard command with this commit ID. And if I do a ls now, you can see all the files are there. And if I get log one line, you can see once again all the commits are there. So the head has moved back to this commit ID. Okay, dear students, that is enough for today. In the next session, inshallah, I will discuss about the concept of branching, merging, and handling merge conflicts. I will also talk about and practically show you how we can work with remote repositories using some web-based hosting services like the GitHub and the Bitbucket. By that time, please practice whatever we have done today. Hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Wish you all the best, happy learning, and Allah Hafiz.